Okay, everyone, today we're going to be learning about how to find the stationary points of a function and then the nature of those stationary points and also where the function increases or decreases. Okay, let's start. Okay, so we're going to be looking at y equals x cubed minus 4.5x squared minus 30x plus 5. So to find the stationary points, the first step that we need to do, like the very first step that we need to do, is to find the first derivative. Okay, so what is the first derivative? The first derivative, the symbol is dy over dx or f prime x. And because the question is y, so the first derivative is going to be dy over dx. Okay, so dy over dx. So this is like the very first step. Oh yeah, by the way, this video, we're only going to be using first derivative to find the stationary points and the nature of the points, okay? There's going to be a method that uses second derivative, but we're not going to be doing it today, yeah? Okay, so dy over dx. At this point, okay, by this point, you should already be able to derive, yeah? So if you don't know how to derive yet, you need to check on my first video, like the differential calculus. You need to check that out first. Okay, so let's derive x cubed. X cubed is going to be 3x squared. Yeah, because you ditch the 3 to the front. Okay, negative 4.5x squared is going to be 9x to the power of 1. Remember, you ditch the 2 to the front. So 2 times 4.5 x, and then the 2 at the top, this 2 here, you're going to minus it by 1. So 9x to the power of 1. The negative 30x, it becomes negative 30. Okay, and the 5 is a constant, so it's just a 0. Okay, so we're just going to leave the 5 alone. Okay, so we have our first step. So we have this. So I'm going to like highlight it with yellow. So we're going to be using this, yeah? We're going to be using this back and forth. Alrighty, so now let's do our first assignment. That is to find the stationary points. Okay, stationary point. What is a stationary point? A stationary point is a point within the function that the first derivative or the gradient or the m or the slope is 0. Okay, so what's stationary point? It's when the dy over dx equals to 0. Okay, because when the slope is 0, yeah? So that's why we're going to be using the one that we highlighted to find the stationary point. So that's what we're going to do. So dy over dx equals to 0. So we have 3x squared minus 9x minus 30 equals to 0. Okay, because we're looking for stationary points, then we're looking for the x. Yeah, we're looking for the x there. We have 3x squared minus 9x minus 30 equals 0. I'm going to divide everything by 3. Do I need to divide everything by 3? No, but then it's just going to be easier that way. So I'm going to divide everything by 3 because I need to find the x, because I need to factorize the left side. So I have x squared minus 3x minus 10 equals to 0. Okay, remember, you can only divide everything by 3 when the other side is 0, okay, because 0 divided by 3 is 0. If it's not 0, you don't just divide by 3, yeah, you have to do something else. Okay, so I have x squared minus 3x minus 10 equals to 0. I'm going to factorize that. By now, you should be able to factorize. Okay, so I'm not going to teach you how to factorize in this video. All right, let's factorize x squared minus 3x minus 10. You need to find two numbers. If you times equals negative 10, if you plus equals negative 3. So I'm going to put x here, and I'm going to find the two numbers. And then I already know the two numbers is going to be negative 5 and plus 2. How did I know that? Because I already know how to factorize, and you should also too. If you don't remember, you need to check the other video. All right, so x minus 5 and then x plus 2 equals 0. So we know that x equals 5 and x equals negative 2. So we already have parts of our stationary points, which is 5 and negative 2. Okay, because it says it's a point, so we need the partner of the 5 and negative 2, because that's just the x. Point is x comma y. So a stationary point is okay, I'm gonna put the low one on the left side. Negative 2 comma something and 5 comma something. So I'm putting the negative 2 on the left side, yeah? So how do I find the partner? How do I find the partner of negative 2 and 5? Because that's the y, I'm going to put it in or substitute it in the original formula. Okay, so I'm going to circle it red. So people, do you see this? I'm circling it red. Yeah. So that's how I'm going to find the y. I'm going to use that. So I'm going to input -2 there, okay, in the x cubed minus 4.5x squared minus 30x plus 5. I'm going to input it there, and then I will have, using my scientific calculator, I will have 39. Okay, I hope I'm not wrong. You can check also, yeah? So I will have 39, so I'm going to put 39 here. So the coordinate, one of the coordinates is -2, 39. And then the 5, I'm going to input also in the x cubed minus 4.5x squared minus 30x plus 5. And I will have -132.5. -132.5. Okay, so I already have the stationary point. So this guys, these two here, they are the stationary points of that function. Okay, so done, we got the stationary points. Now our next assignment is to find the nature of those two stationary points. So what are the nature of the stationary points? They have three. One of them is local maximum, local minimum, and inflection points. Okay, now we want to find out if -2, 39 and 5, -132.5 is it maximum, is it at the maximum, at the minimum, or at the inflection point. Yeah, we're going to find that out. How do we do that? Okay, again, we're only going to be using the first derivative, because to find the nature of the points we can use the second derivative, but we're not doing it today. Yeah, okay, so let's use the first derivative. I'm going to use the help of a table. So I'm making a table. So the second step, we want to find the nature of the points. I'm going to use a table to help me. So I'm sliding it up. Okay, hopefully I'm not covering the important information that we need. So I've got x here, so you need to pay attention to what I'm writing. Okay, I'm going to shade. Okay, and I'm going to just pull a little bit. Okay, so you see I have this. Okay, I need to have enough column. And I'm going to put -2 on the left, because so the one on the left is always like the lower one, and 5 here. Okay, and then if you see, how come I have like I put space in between them, because we're trying to test the neighbors of -2 and 5. The neighbors are the numbers that are on the left side of -2. So that's on the left side of -2, between -2 and 5, and on the right side of 5. Okay, so we're going to test the numbers on the left, between, and on the right side of -5. So I'm going to write, on the left side of -2 is -2 minus. In between -2 and 5, you can either put -2 plus or 5 minus, it's okay, yeah? And on the right side of 5, okay, I'm going to put 5 plus. Now, so what is -2 minus? It's just any numbers on the left side of -2. And I think we're going to choose -3, yeah? So -3 here. I'm going to put a circle so we don't forget. Why don't I just put -3 there? Because somebody else might put -4, or somebody else might put -2.5. So I'm putting -2 minus, but then I put a small -3 at the top, yeah? And then the one in between -2 and 5, I'm going to choose the easiest number, which is 0. Okay? Can I put 1? Yeah. Can I put, because -2 and 5, can I put 4? Yes. But then, why put those numbers? Let's put the easier one, which is 0. Okay? And on the right side of 5, I'm going to put 6. All right. Okay. What we need is actually the symbol. Okay? The symbol of the dy over dx of those neighbors. Okay? Let's see. Okay. If you're kind of, what do you mean? Okay, let's see. Okay, so now I'm gonna fill in this bit here, and that. Okay, so if you see, what is the dy over dx at x equals -2, and what is the dy over dx at x equals 5? The dy over dx is 0 and 0. So the dy over dx of -2 is 0. The dy over dx of 5 is 0. Why? Because they're the stationary points. Yeah, the stationary points. And that's how we got in the first place. We did dy over dx equals 0 to get -2 and 5. So there's 0. Now we need to test what's the dy over dx at x equals -3. So we're filling this one now. There. Okay, so I'm going to erase this so we don't get confused. So we're going to fill in the the one on the left side of -2, which is -3. If you choose -4, then you put in -4. Okay. So what am I gonna do with the -3? I'm gonna input it to. Okay, I'm gonna circle it, guys. I'm gonna input it to here. Can you see there? Okay, I'm gonna circle it with red. See dy over dx. I circled it red. Yeah. So I'm gonna input it there, and I'm gonna just write down the symbol. So there's a -3, so I'm inputting 3, and then times. Okay, -3 squared, and then -9 times -3, and then -30. Okay, so I'm inputting the dy over dx. I'm replacing the x by -3. Okay, I need to be careful. I don't input it. I don't miss anything. Okay, and I have a 24. Okay, 24 is positive number. I don't need to write the 24. I just need to write the plus. Okay. Now, I'm going to find the one at point 0 because we chose 0 for the point between -2 and 5. So 0, 0. I'm going to input in the dy over dx, the one that I just circled. Okay. 0 is an easy one. If you input in the 3x squared minus 9x minus 30, you'll get -30, which is negative. Oopsie, I used the wrong one, which is negative. Okay, so 0, you put in the 3x squared minus 9x minus 30. It's -30. Yeah, it's negative. There's a negative number, so I put negative. Now I'm gonna check on the right side. Okay, so I'm gonna erase this bit here. So I hope you guys are following what I'm doing in my screen. I'm gonna see. You see that? Yeah. I'm gonna find the symbol of the dy over dx at x equals 6. I'm gonna change. Okay, so 6 now. So you can pause and you try to find it. So you input the 6 on the dy over dx, and I get 24 again. Okay, and it's positive. Okay, so positive. Okay, so I have, because I don't need the value itself, I just need the positive or negative. Okay, so let's fill in the next boxes on the table, and we're gonna fill in this. So whoops, what did I do? Okay, so we're gonna fill in these. Okay, so how do we fill that? Now we're gonna look at the dy over dx. Now guys, you should know, if the slope or the dy over the dx or the first derivative, if it's positive, then the graph is going up, so go up. Okay, if it's 0, it's just like flat because there's no changes. If it's negative, it goes down. If it's 0, it goes flat. If it's positive, it goes up. So our graph later will look like this. So at point -2 and point 5, so the -2 is here, -2 comma, okay, what's comma 39 is there, and then 5 comma -132 point, whoopsie, okay, 132.5 is there. Yeah, because at the 2 it goes up, at the -2 it goes up, and then at the 5 it goes down. Yeah. Okay, so what are the natures of those 2 points? So we can conclude that, okay, I'm going to scroll up, -2 comma 39 is the local maximum. Why is it the local max? Because it's at the top. And then 5 comma -132.5 is the, whoops, I need to write it down. So 5 comma -132.5 is the local minimum. Okay, maximum. Okay, why do we have local? Because like if you check on the graph, it might not be the real maximum minimum, because maybe the graph goes way up, or the graph goes way down. Yeah, that's for another day. Okay, so we found the nature of the 2 stationary points. -2 comma 39 is local maximum. 5 comma -132.5 is the local minimum. Okay, we're done with the assignment number 2. Now we're going to do assignment number 3. Okay, assignment number 3 is to find when the function increases or decreases. So guys, because we're only using the first derivative, we're going to use the help of the table that we just did before. So because we're doing this one, okay, so I'm gonna this, okay, we're doing the third one. We're going to use the table for us to solve it. Okay, so number 3, whoopsie, wanna find when does it increases and when does it decreases. Okay, sorry, my writing is not good. Okay, so let's have a look at this there. Can you guys see the arrow that I just made? So I'm gonna highlight this. I'm gonna highlight with pink. See this pink arrow that I made there? Okay, so we're gonna like find, oh, when, look at the interval. When does it increase? Now people watch, it increases here. Okay, I'm gonna -2 to the left. Increases. So it increases before -2 and then after 5. So that's what we're gonna write. So it increases at x smaller than -2 or at x bigger than 5. And when does it decreases? So people have a look. Here I'm circling. It decreases between -2 and 5. Okay, so it's going to be -2 x 5. Okay, so we got the answer for all of our 3 assignments. We got the stationary points, which is -2,39 and then -132,5. -2,39, we found out that it's the local maximum. 132.5 is the local minimum. And then we found where the function increases and decreases using the table. It increases before -2 and after 5, and then it decreases between -2 and 5. Hopefully, this video will help you know more about finding the stationary point, the nature of the points, and also when the function increases and decreases. Okay, thank you very much. I'll see you next time. Bye bye.